Today I'm gonna talk about the last operation of complex number division. Okay, before I gonna solve the following examples, I would like to mention a little bit more about the properties of complex number. The first one is I square equals -1, and the second one is z times z bar equals a plus bi times a minus bi equals a square plus b square. And here z bar is the conjugate of z. What is the conjugate? Let's take a look. If z equals a plus bi, the conjugate of z gonna be a minus bi. What does that mean? That means we change the sign of b to the opposite sign. Okay, so for example, if b is positive 5, then the conjugate gonna be -5. Okay, -5. If b is negative, for example, -6i, then the conjugate gonna be positive 6i. Okay, so that's the principle for the conjugate. Now let's take a look the first example. For the first example, we can easily tell we have a, for the first complex number, a equals -5, b equals 1. Okay, b equals 1. And we can tell for the second complex number, we have a is -5, and for the imaginary part, that is -1, right? -1. So b becomes opposite sign. Here's a 1, here's a -1. So it's opposite sign. That means we can apply this property, z times the conjugate of z here, or z conjugate. So we can plug in -5 square plus b square. That equals 25 plus 1 equals 26. Okay, so that's the first one. Now let's take a look the second one. The second one, we wanted to rationalize this fraction. Actually, we wanted to write this complex number as standard form. What does that mean? We want to remove the I from the denominator. Okay, now let's focus on the denominator. We can tell here in the denominator we have the complex number 8 minus 8i, that is a equals 8, b equals -8, right? So in order to remove the I, we're gonna use this property. Let the denominator times the conjugate of this complex number. Okay, so what are we gonna do is 6 subtract over 8 minus 8i times this complex number's conjugate. So it should be 8 plus 8i. That's the conjugate of complex number 8 minus 8i. Change the b to the opposite sign. At the same time, we're going to times the same complex number. Now we can simplify it. 6 times 8 plus 8i, and for the denominator we have 8 minus 8i times 8 plus 8i. Okay, and for the numerator we can use the distribution. So 6 times 8, 6 times 8i, and for the denominator we can apply this formula. Since a equals 8, b equals negative 8i, negative 8 square, right? So we have 8 square plus negative 8 square. Okay, and we have 48 plus 48i, and 64 plus 64. And again we can simplify and spread these two terms. We have 48 plus 48i, 64 times 64 plus 64 is 128. We can split these two terms, 48 over 128 plus 48 over 128i. Now we can continue to simplify 48 over 128. How to simplify? I'm gonna write it down here. 48 over 128. We will try to find the common factors. So for example, 48, we can easily say, hey, that is 4 times 12. And for 128, you can write down as 4 times 32, right? So we cancel out. And the 12 over 32, you also can write down as like 4 times 3. And 32 can be written as 4 times 8, right? So we cancel out. We have 3 over 8. Now we can write the simplified format. That is 3 over 8 plus 3 over 8i. Okay. Now let's take a look. The second example. Again, we're gonna focus on the denominator. What is a? A is 8, b is equals 1, right? So in order to remove the I from the denominator, we're gonna use this property. So we have 8 minus I, 8 plus I. We want times what? Times the conjugate of this complex number. So what is conjugate of this complex number? That is 8 minus I, right? Change the sign of b to a negative. Okay, just change the sign of b to negative, right? Here positive, negative. So we have the numerator the same, right? Now combine the terms together. And for the numerator, we can use the distribution. 8 times 8, 8 times negative I times 8, negative I times negative I. So 8 times 8, 8 times negative I plus negative I times 8, and plus negative I times negative I. And for the denominator, we know a equals 8, b equals 1, plug in here. So we have 8 square plus 1 square. and we're gonna get 64 plus 1, and for the numerator is 64 minus 8i minus 8i, and negative negative positive I square. We can simplify, so we can simplify it. Simplify is 64 minus 16i, and here the I square is what? Is negative 1. Okay, I square is negative 1, and divided by 65. Okay, so 64 minus 1 is 63. Subtract 16i divided by 65. And if we wanted to simplify it or spread these two terms, right? We want to spread and the second term. Okay, we have what? We have 63 over 65, subtract 16 over 65i. Okay, now let's take a look at the last example. For the last example, we're gonna follow the same strategy. We're gonna focus on the denominator. A equals 3, B equals 4. Okay, so now we have what? We have 3 plus 4i. We want to times what? Times the conjugate of this complex number, that is what? 3 minus 4i. Okay, so times 3 minus 4i for both numerator and the denominator, and we're gonna get 3 minus 4i and 3 minus 4i times 3 minus 4i. 3 plus 4i times 3 minus 4i. Okay, and for the denominator we can use this formula: a squared plus b squared. A is 3, b is 4. Okay, so it's 3 minus 4i, and this guy will give you 3 minus 4i, and 9 plus 16 is 25. Okay, and we can spread the terms. Gonna be 3 over 25, subtract 4 over 25i. That's it.